For tonight's homework, you're going to complete page 14 and correct it with this section. What is the area of each section of the area model? Red yellow has an area of this amount, and if I divide everything into about equal sized pieces, I can see that it looks like around 1/10. The area of red blue looks similar, like about 1/10. The area of green yellow seems like it's worth more, looks like it's about 4/10. And the area of green blue looks similar to green yellow with 4/10. I can also simplify that to 2/5. For each section, what fraction of the whole square is this? Again, looking at what's up here, these guys are kind of repeating. Red yellow is 1/10. Red blue is 1/10. Green yellow is 2/5 of the whole square. And green blue is also 2/10 of the whole, or 2/5 of the whole square. So you'll notice these guys are matching in terms of the areas and the fractions. And then see, how do the fractions in the previous section compare to the probabilities of each section? Noting at the top, the probability of red yellow was 1/10. And the area of red yellow is 1/10. So basically they are equal to each other. The probabilities and the areas match, which is what makes an area model such a helpful model. Now let's create area models to represent the probabilities of each combination of buckets. So the first we see is 2 red to 8 green in bucket 1. And so 2 red to 8 green is a ratio that we could actually simplify so that we don't have to draw quite so many sections. 2 red to 8 green could be simplified to 1 red to 4 green. And so instead of drawing 10 sections up here in order to do the 2 to 8, I could actually draw 5 sections in order to do 1 to 4. And that just makes it a little bit easier to set up. So setting this up here, I'm going to divide this into fifths, right, or 5 sections. I have 1 red and I have 4 green. And another way that you could do this as well is you could simply label this as green, and you could erase these lines here so you can see that there's about 1/5 of this is red and then 4/5 is green. That's what creates that 1 to 4 ratio. And then in bucket 2, we have 5 yellow to 5 blue. And you may notice you can simplify that ratio to 1 yellow to 1 blue. And so that means I can pretty much just divide this right here in half, and I'm going to label part of it blue and part of it yellow. And so at that point I can see how much of my sample space I have for each combination. Now looking at B, I see the same thing, 2 red to 8 green in bucket 1. So I'm going to set that up just like before. So I have red here, green here. This is in bucket 1. Again, red is about 1/5 of the total, since green is going to be 4/5 of the total. And then I have 10 yellow and 10 blue. Again, I can simplify 10 yellow and 10 blue as a 1 to 1 ratio. So I'm just going to divide this right on in half again and set up red and green. Or I'm sorry, I'm going to set up yellow and blue. That looks a little bit better. And now we're moving over to C, 1 red and 4 green in bucket 1. So notice I'm pulling out here 1 red and 4 green. I can't simplify that any further. So I'm going to divide this into 5 sections so that I can make it 1 red and 4 green. And again, you can also set it up like this, where you have just all the greens kind of clumped together, and then 3 yellow and 3 blue. And I notice that's the same as that 1 to 1 ratio, so I have yellow and blue right here. Last one, 2 red and 2 green in bucket 1. So I'm going to think 2 red to 2 green, that's a 1 to 1 ratio. So here's red and here's green. And then 4 yellow and 4 blue, that's also a 1 to 1 ratio. So I'm going to set up my yellow and my blue. So now, which of the following combinations above could be the contents of the 2 buckets in the original problem? So here's what the area model looked like in the original problem. Again, when we combine red and yellow together, we make orange. So they've kind of color-coded this so you can kind of envision it. And so if I'm looking at these sections here, over here I notice I switched blue and yellow, but I can switch those back if I'd like. And I see for these, it looks like it's about the same amount in A, B, and C. My section here in D looks a lot bigger. And so as I'm comparing them, it looks like A, B, and C could potentially be similar to the model that we saw in the first problem.